Hello, welcome guys. Welcome back to our Thursday webinar, and we'll be solving problems today on statistical estimation of the assignment problems and whatever doubts we have regarding the whole, statistics. And then our estimation syllabus will be is on the way of its completion. So we'll be discussing a lot of interesting problems of the assignment. So perfect, guys. So let's catch it up. And any doubts from your end, guys? Any doubts from your end that you want to share? Um, yeah, or I will just get straight into the assignment problems, guys. What do you think? Our core issue of Tishika, Shana, Proma. Sure. Okay, so let me start with the problems that we have. Let's do this assignment problem. Okay, the problem demands that if fx given theta is equal to half theta square cube x square e to the power minus theta x greater than 0, uh, some calculus shows that the mean of this distribution is 3 by theta. Okay, you can easily do this. Like you can do the x, like if x follows this f, if x follows this f of x given theta, then you can show that expectation of x turns out to be 3 by theta. Okay, so can you tell me like which type of integration it will be important over here? So it will be half theta cube x square e to the power minus theta x, right? 0 to infinity. So which integration will be helping us to find the distributor, the expectation, guys? Can you tell me? Any ideas? Because this is very important for you to know. Like gamma, very good, super, gamma. So we need gamma integration to solve it. So remember that. So this during this time of last moment preparation, we need to understand the what things we will what things we need to remember while in the examination hall. Perfect. So this is 3 by theta and its variance is sigma square 3 by theta square. So you understood that. That's really easy to prove. You can use it by gamma integration. So why I'm writing this, because these are the key words that you should remember, and you should make cheat sheet of. Okay, and it's asked that from a random size, from a random sample. Okay, it's asked from a random sample. We are taking this. So from a random sample of size n, x1, x2, xn, we're taking this xn bar, which is the sample mean. So it's asked to find its mean and variance. So let's find out the mean and variance of xn bar. So we given that we know the behavior of xi's, can you find the mean and variance of xn bar? It's very easy, right? How do you find it? How do you find xn bar ka mean and variance? Xn bar ka mean is what? Expectation of x, right? That is 3 by theta. It's very easy to find it out. And expectation and variance of xn bar is what? It's variance of 1. I'm doing it from the first principle, but I will not do it soon. So it's 1 by n, so 1 by n square is coming out, and it's n times, since xi's are independent, so n times variance of xi, and so it will be 3 by, it will be 3 by n theta square. Okay, so that is what the variance is all about. Very good. So we have done the first one. Any doubts in this, guys? I hope no doubt is there in this. So now we need to use this idea to find out the so let's revise Kremer overbound once again. So Kremer overbound, we need to find out what. Let's revise it. Let's revise the algorithmic steps. Number one step, I'm writing it again, is find the joint distribution. Okay. Number 2 is find this static. This is called the score function. Find the score function, that is del theta dd theta, rather f theta of x. Sorry, there's a log over here. This is a step 2. It's a score function step. So we are revising the steps to find the CRLV. Next one is what? The next one is find variance of u or minus of expectation of del square del theta square ln f. This, any one of them. Okay, superb. So, and this is what the CRLV is. But remember, there is an assumption over here that support doesn't depend on theta. Okay, perfect. Okay, so with this, let's find out the CRLV in this case. So we have sample means unbiased estimator, that we know that. So show that there is no unbiased estimator, better sense in the. Okay, so that means what it's asking? It's asking you to prove that xn bar is the UMVV, right? No unbiased estimator is there in better sense, that no, that is the it's a UMVV. Okay. So proof Kramer-Norman for g theta, any g theta. So to find the UMVV, therefore what we need to find? So any g theta ke liye, okay, so let's find the g theta is equal to mu over here, that is 3 by mu, 3 by theta. So let's find out for mu. Okay, let's find out for mu whether this is the UMV or not. So here g theta is equal to 3 by theta, which is equal to mean. So it's asking you to prove that xn bar is UMVUE of 3 by theta. This is g of theta. Okay. So the Kramer-Norman is what? It's equal to, if you remember, it's equal to g dash of theta whole square by, let's call this I of theta by I of theta. Okay, I'm doing it very slowly and very step by step manner. So now, so let's do the step in this case. So let's find out the f theta of x curl, which will turn out to be product of this. So let's write it down properly. It's 1 by 1/2 times theta cube into x square into e to the power minus theta x. There will be product of it. So what we will do? We'll do product of it, since they're all independent, and here it will be xi. And if we multiply it, we will get what? 1 by 2 to the power n times theta to the power 3n times product of I from 1 to n xi whole square times e to the power minus theta summation of xi. This is what we get over here. Perfect, very good. Ha, nice. So now let's take a log of it. That's the first step. The second step is what? Find the score statistic. So it's d theta log of f theta of x curl. So it's d theta. So let's take a log of it. Log of this is constant. So let's write it as constant. It is like, it's easier hack for you. Plus this theta, it will be 3n times ln theta, plus again some constant with respect to theta, so that its constant is within this. So No need to write it down. And it's here minus theta summation of 1 to n this. Great. Very good. Superb. Okay, so we have found this out, and let's see what is the value. You see it's 3n by theta minus summation of xi 1 to n. Very good. Very good. Very good. So if you remember, I have given a result last day about this. I've given a result last day about this, if you remember.
Minus double derivative.
No, not that. This one. So how to prove that something is EMVV? It's from Kasselberger. Okay. So Satej told me this one first. So if you think about this, so you see, if you write this U, so it can be written like this also. So it's another problem solving step. It can be written like this. You can do it, or you can just do it directly like this, using this theorem, just to avoid the first step. So if you observe here, we get what? If del theta, if x curl theta, like log of the joint distribution, can be written as a theta into wx minus this, then we can say that wx is a UMVV of this. Okay, we can tell that. So therefore, using this result, what we have got over here, we have got that del theta log of x theta this, it comes out to be what? N times 3 by theta, rather minus, right, like this, minus n times xn bar summation xi minus 3 by theta. It's coming out like this. So this is the a theta part, this is the wx part, and this is the g theta part. So it can be like this, if and only if wx attains the CRLB. So you can prove it, okay, but you can prove it like this. Using this result, you can do this. Okay, that's one of the most easiest, like one of the more easiest way out there, like to use this theorem out here. So therefore wx curl is equal to summation of xi is UMVV of 3 by theta, which is equal to mu. Okay, we can do like this. Okay, see, in case you don't remember this result, I want to do it from the first principle. That's my habit, you know that. So let's do it from first principle, and it's very easy. Summation xi ka, you can find it out, right? Because that's what you have found it over here, variance and stuff. Okay, so let's find it out. Let's find it out. So therefore, what do you find out? What do you get? Understand this very carefully. Understand this very carefully. That expectation. Okay. So if you get something like this, let's try to show this in some sense. If you get something like this, why it attains the CRLB? Can someone tell me why it attains the CRLB? If you get something like this, why it attains the CRLB? And if and only if. Any ideas? It's telling that if a theta times, I'm just doing the general result, if this is del theta log of x theta, then if and only if is unbiased, and is unbiased is very clear, and attains CRLB. It's an if and only if condition. So let's do this way. So I'm proving this because you can use this result in general way. You can use this result in a general way. Okay. I'm doing this because you can use the result in a general way. So let's prove it out. So if this is the case, if this is the case, then let's prove it. So any ideas? Like you understand CRLB is what? CRLB is. So what we have to show? We have to show that it attains CRLB means what? Variance of WX curl. So number one, WX is unbiased. Is unbiased and attendance CRLB is WX is unbiased. And attendance CRLB means variance of this is what? Variance of del theta of log this, right? This is what we have to show, right? So what we can show over here. Yep. So what we can show over here, tell me. What we can show over here. So if this is equivalent to this, so if we just prove this, then it's done. So if, so of course we know that, so there's a result, this is u. So there's a result that expectation of u is equal to 0. There's a result like that, you just assume that. So if that is true, that means if you like, since it's true, okay, so what you can do is that, like this unbiased is just known case, okay, it's like very easy case to understand. It's unbiased if and only if this is happening. So you have to show that therefore variance of u is what? Variance of u is something like this. So what is variance of u? Variance of u is what? Variance of u is a theta whole square variance of x, right? Variance of u is what? A theta whole square variance of x. Sorry, variance of wx, I mean. Okay, I think it in the CRLB means, no, it as CRLB means, um, just give me a minute. It doesn't CRLB means for, sorry. So it means that,
Hello. Hello.
just give me a minute.
Hello.
1 second, guys, 1 second, just give me a minute. Yeah, hello, sorry for the delay. Actually, an important call from the bank came. So yeah, so what you have to show here? So you have to show that g dash theta whole square by variance of u, ठीक है? इसका, this is u, so इसका variance like I theta is what? This variance. So I did the mistake over there. So variance of u is equal to variance of Wx. That you have to show exactly, right? So variance of u is what? As I've shown, it's g dash of theta by variance of u. I have shown it's like a theta whole square by variance of Wx. It's asking that you have to show that it's equal to variance of Wx. So do you think it's true? So what is the way out? Any ideas? This is exactly what you have to show, right? So you have to show that variance of Wx is equal to what? G dash of theta by a theta modulus. This is what you have to show. Okay. Now, this is what you have to show now. You know that u is equal to what? U is equal to a theta Wx minus g theta. Now you also know that, yeah, if you find out del theta square of this will be turning out to be what? It will be turning to a dash of theta Wx minus iska product, so it will be a dash of theta g theta, okay, minus a theta g dash of theta, okay, by product rule. So you get a dash of theta Wx minus g theta minus of a theta g dash of theta. And you know that if you take a minus of this, so you know that variance of u is also same as what? Variance of u is also same as what? Minus expectation of what Tishika told. So it turns out to be what? This is 0 since this is unbiased. So it turns out to be a theta g dash of theta, which is positive, of course, which must be positive, otherwise it's not done. And you also know that variance of u is what? We know variance of u is this. It's also equal to g dash of theta square by variance of Wx. So we get what? We get that variance of Wx is nothing but g dash of theta by a theta. And that is exactly what we have to show. Uska modulus, this is always positive, otherwise this wouldn't have come. So we understood that this is the, so all of you understood the proof, guys? All of you understood the proof? Anyone who didn't understand? Any doubts, guys? So I proved that this happens, like it attains a serial B if this happens. So if this is the structure of the whole thing. Did you understand? Shana, Orko, Devan, Mansi, Nikhil, Paulami, Pratiksha, Proma, Rishav, Shoikat, and Tishika, Shuprabho. Any doubts, guys? Do I repeat anywhere? Please tell me if you understood or not. Okay, good. What about others? Very good, superb, superb, superb. Very good. So you understood. Superb. So we have got that this proof is important. So we have got that Wx is the UMVU over here since it attains the Kremer bound. That's very good. Okay, that's really good and perfect. So we have understood that it happens and this is solved. Okay. So all of you understood the solution? Any doubts? No, I guess. So Devan, it's your first class with us. And Devan, it's your first class with us.
Yes, sir.
Okay.
No, I have done 2, 3 classes earlier also.
Okay. Thank you. Thank you. Okay, perfect. So let's move to the next problem. Can you please mute yourself? Thank you. So let's move to the next problem. Just give me a minute. Okay, this is another interesting problem. Although this problem will not come in IIT JAM, but this problem is important for ISI MStat. So, because the quality of problem is really important here. Maybe I will do an easier case of it, but you're learning really good mathematics and statistics and probability over here, so we must do this problem. Yeah. So okay, just write a boom if you are very confident and very confident with the process of CRLB that I have told, algorithm of CRLB that I have mentioned over here. If you're confident with that, if you're confident with this algorithm, please write a boom. I think many of you must be confident. So this is very important, and you should be able to do that because I have done this a lot of times. Very good, superb. Okay. Okay, so let's move on to the problem now. And here the problem is a bit difficult. Okay, but here I will tell you what is the least square estimate. And okay, this is a bit okay, this is one dimensional stuff, so it will be easy for you. Okay, so it's asking the regression problem, a type of regression problem. And let's see. So x is a observation, single observation x, and it has a constant a times theta plus epsilon, where epsilon follows this. So understand x therefore follows what? X therefore follows a theta plus normal 0 comma sigma square, which is same as what? Normal a theta comma sigma square. So therefore x follows normal a theta comma sigma square. Okay, so now we have to find the least square estimate of this. So let's say x1 x2 xn is there. It follows, all of them follows normal a theta comma sigma square, IID. Okay, that is the this is the regression setup. Okay, that you all know. Now understand this very carefully. We do find the least square estimate. So what is the least square estimate? It's very easy. Let me revise it with you. So we first find the loss function. Which is summation of I to n what? Xi minus a theta whole square, and that is the loss function, and we're trying to minimize it. Okay, because minimize it with respect to theta. A is known, like a is a known constant, theta is unknown. Theta is what? We need to find the estimate of. A is a known constant. So this is a loss function, which is a function of, you can call it L of theta. Okay, let's not write it. You can call it small l of theta, or not small l. Let's write it different. You can write just loss of theta, because L of theta can be like, you can um, confuse with the likelihood. And what we do is that now we minimize this with respect to theta. So we do the derivative of loss of theta, we equate it to 0 to minimize it. That's the rule of calculus, okay, finding the minimum and maximum. And we get d d theta summation of I from 1 to n xi minus a theta whole square. So we get summation of I to n uska del theta. So we get it's equal to, first of all, xi square is 0, that will be 0 with respect to del theta. Theta square, it will be theta twice theta, okay. And okay, there's, I am missing something out, so I'm sorry. Actually I can't, this portion of the screen is broken, so I cannot see it. Let's write it down. So loss of theta is summation of 1 to n xi square plus a square theta square minus twice a theta xi. So if you do del theta of loss of theta, you will get, since summation and in differentiation can, it's finite summation, it can interchange, this will be 0 plus it will be twice a square theta minus twice a xi. This will be equal to 0, because you want to minimize it. And also let's do it double derivative to see it's really minimum. So if we do double derivative of it, we will get 0 plus twice a square minus 0 plus 0. So it's turning out to be n twice n a square, which is, remember, greater than 0. So if something happens, that will be minimum. So we get from here, it is 0, so we get from here twice n square theta, a square, twice n a square theta is equal to twice a summation xi 1 to n. So a cancels, 2 cancels, and we get that theta is equal to xn bar, n comes here by a. That's a very reasonable estimate, because understand that if you see expected value of x is a theta, and therefore if you replace expected value of x by xn bar, it's xn bar is equal to a theta by method of moments also, and we get that theta is equal to xn bar by a. So it's a very reasonable estimate, okay. That's a very reasonable estimate by this least square estimate. So we get this theta hat is equal to this. So we get theta hat is equal to xn by this. Now the question is that, is it a good estimate? So we can find out whether it's UMV or not. Okay. Also verify it attains the criminal or it attains the criminal or not. Okay. So you can easily understand that theta hat. So let me write down the whole model out here again. X1 x2 xn follows normal a theta comma sigma square, and xn bar is what? So sorry, theta hat is xn bar by a. So expected of theta hat is xn bar, expectation of xn bar by a. So xn bar, expectation of xn bar is what? We know it's a theta. So it's expectation of xn bar by a. We know it's a theta by a, which is theta. So this is unbiased. So therefore we can find out among this unbiased set of estimates, there's a natural tendency of the statisticians that whether it's an UMV or not. So how we can find whether it's an UMV or not? Let's use, so understand, to use the Kramer overall, you need to have a distribution, okay. And let's write it down. Let's write it down because we need to find the joint distribution of that. So step number 1 is what? The joint distribution. Okay. So we are joint distribution. Now do you get product of I from 1 to n? So number 1 is the support is not dependent upon theta. Okay, you can easily understand that. It's upper half plane. And if you do it, you get 1 by root 2 pi sigma exponential minus half x minus a theta by sigma square. Okay, and इसका product है, so let's write it down properly. Root 2 pi whole to the power n times sigma to the power n times exponential minus half sigma square summation of x1 to n xi minus a theta whole square. Superb. So let's write the log of this because that's the next step. So let's write dd theta of, let's write in the next page. So dd theta of log ln theta x bar is what? So see, we need to find out the sort of del of del theta, okay? So we can assume this part is constant. So, oops. We can assume this part is constant easily. You can write it as with respect to theta. So therefore it's constant times exponential this. So let's write it down here. So you get dd theta log of constant. So that's itself a constant. C dash plus C dash plus just give me a minute. C dash plus, if you take a log here, we get minus 1 by 2 sigma square summation 1 to n xi minus a theta whole square. Okay, if we get that, let's differentiate it. So it's 0 and so d theta, you can easily understand. Let's write it down again. Minus 1 by 2 sigma square summation of this xi square plus a square theta square minus twice a theta xi. So you get minus, first one you get what? It's a constant result of theta. So first one is called 0. The second one is what? Second one you can easily understand, it's twice a square theta n by twice sigma square minus, is to understand same thing is going on. If you see the least square estimate, same equations are coming up. If you observe, you get this, something like this. 1 by 2 sigma square. Okay, you get what? Twice a theta summation xi, twice a summation xi from 1 to n. Minus gets over there, so that's why I got it. Minus twice a square n theta. This is what you get. Let's take all the constants out. So you get 2 theta, so a by a square, a by sigma square, a square I should take out. Also n out. So you get Observe xn bar by a minus theta. So using this result again, we can understand that xn by a is the UMV of theta. Did you understand the proof, guys? All of you? Write a boom if you understood the proof. Therefore, you have found out that xn bar by a is the UMVV of theta. So least square estimate is the UMVV. So it's a very good estimate. Did you understand it, guys? Please write a boom in the comments. Very good. Super. Very good. So this kind of problems can come up. Okay. This kind of new problems can come up. So one suggestion from my end, if you have your basic principles and algorithms and way of working is correct, guys, it's an enjoyable process of doing this. Okay, you're just fasten up the process. Initial all these mock tests are happening, it's to getting accustomed to all the algorithms and all the methods. The next four mock tests, last four mock tests, full mock tests are to make it faster. That's why you have kept this 10 mock tests. This is the idea, guys. Always use the basics to get accustomed to the whole algorithms and processes and making a cheat sheet. And the second process is making it faster. These are the only two processes. The first part is learning that you already learned, and I think you're quite capable enough, all of you. Now the part is to finally understand which are really important out of all the things you have learned out, and then the final step is making it faster. These are the three exam preparation steps. Okay, and yeah, so when you will be doing it faster, then you will rate that 8 to 10 out of the whole thing. Now you have understood the algorithms and all the thing. That's why you're leveling like 4 to 7. Okay, medium. Initially when you joined Cheenta in the initial days in February, January, like now March region, you were in the initial zone, bad zone. Slowly you learned, you are now confident in the theories and the algorithms. Now you have to apply it faster and make the process faster. That's it. To know that, you have to also know the process and the results and the algorithms well. That's my part of the job that we are doing. Okay, perfect. So we have solved this problem, and there's, let's see if there's any other. Okay, so we have found out Fisher information. In fact, we didn't find out Fisher information. We did it in a different way because we have proved it already. Okay, very good. So let's see if you have any other problems left. Okay, so I think okay, so have we done problems enough on completeness? So any topics that we have missed, guys, you want me to do problems on? So out of estimation, the three problems, three sets are there. One part is unbiased, I will tell you, unbiased, bias, MSc, CRLB, and UMVV. This portion, CRLB, UMVV. The other portion is this: sufficiency, completeness, Rao Blackwell, Lemma and Sheffe, and UMVV. So, are you confident in the first one, guys? Are you confident in the first one? All of you? We have done a lot of problems on the first one. I hope all of you are confident in this region. Also, MLE is there. MLE, MOM. You're confident in this region? First, write a boom or yes if you're confident in the first one. Because I've shared everything what I can do in this region. Please write yes or no or boom, whatever you want to. Are you confident in this region? I think also you're confident, you must be confident in sufficiency. Yeah, bolo. Any doubts you have in the first region? No one confident in this still now after doing so many problems? Okay. Are you serious? Are you not confident? Hi guys. So tell something like I'm not confident. We need to do more problems. So we are still yet to cover this Rao-Black-Lejeune theorem and Lehman-Chaffee, but we have covered it in the crash course. Confident. Very good, Nikhil. Very good. What about Shana, Orko, Deban, Mansi, Paulami, Pratiksha, Proma, Rishav, and Shuprabhu and Tishika? Okay, Tishika is not here. Maybe she left due to network issues. Shoikat, what is your status? Because you will see that once you are good with estimation, like testing hypothesis is super easy, man. I mean, it's so easy. It's just so easy. It's testing. It's, okay, you need to find more problems in practicing the unbiased estimators. Practicing and finding the unbiased estimators. Okay. Okay, how to find an unbiased estimator? That's the question. So, okay, that's a good question. How to find unbiased estimators? How to find? So, one way of finding unbiased estimator is to taking functions of known estimators. So, need to practice more. Okay, fine. So, do our problems. I think we have given problems in our homework solutions. So, do those problems. Okay, do those problems and okay, good. And what about Proma is more confident. Very good, Proma. Very good. And good. And what about sufficiency? Are you confident in that? I've also given a well-defined algorithm for that, and it's very easy, I guess. Last day I discussed a lot of sufficiency problems. Very good. Sufficiency is easy, I guess. So are you still in doubt with completeness? And we have not done Rao-Black-Lejeune theorem though. Okay, so let's do some completeness problems. And I don't know if you have unbiased estimated problems. Let's do them. Just give me a minute. Just give me a minute. Let me check. Okay, Emily is, I guess Emily, all of you are quite confident. Emily and MOM, all of you are confident, guys. I hope. Yup, I understand. Completeness is a problematic. That's true. I know that. Emily and MOM, all of you are confident in that. Okay, so let's do this problem. Okay. This is an unbiased estimate problem. So, I think Shana told that she is facing problems in finding an unbiased estimator. So in fact, we will find something related to unbiased estimator. Let's do this problem. So you have a lot of problems in us. We will discuss them more in our other classes. So fine. So this is called blue. Okay, it's called blue. Best linear unbiased estimator. What is best linear means? It's called a linear unbiased estimator if this happens. summation of x alpha I xi I from 1 to n, and summation alpha is 1. If this is true, then expectation of this is what? Summation of I from n alpha I expectation of xi, which is mu. Since summation of alpha is 1, this is equal to mu. So this is an unbiased estimator, linear unbiased estimator, because it's linear in terms of xi's. So we have to find the alpha I for which it has the minimum MSE. So here minimum MSE is same as, since it's unbiased, it's same as minimum variance, right? We have shown it by a bias variance state of last day. Like in fact in our previous classes. So we have shown that. So we will have to find this alpha I such that this is the minimum MSE. So therefore we need to find the variance. So let's find the variance of this T of alpha 1, alpha 2, alpha n. Okay, because different alpha I vector ke liye we get a different estimator. We find the best alpha I such that we get a best estimator. That's it. Okay. So let's check that out. And it's for mu. So it's same as what? Variance of summation of alpha I xi. Xi is our IIDI. Okay, so we get summation of variance alpha I xi, because since xi is an independent, and we get this is equal to alpha I square summation variance of xi, that is sigma square. It's sigma square summation of alpha I square, I from 1 to n. So we have this, and we have to minimize it with respect to the fact that summation of alpha is equal to 1. Yes, summation of alpha is equal to 1. Now we have this really interesting result, okay, which is called Cauchy-Squart's lemma, Cauchy-Squart's theorem rather, and we have used it in our what? We have used it a lot of times in our correlation modulus correlation square less than equal to 1 proof. So Cauchy-Squart's theorem says that summation of ai square times summation of bi square is greater than equal to summation of ai bi whole square. Inequality holds if and only if ai by bi is constant. This is called Cauchy-Squart's theorem, CST. By this, we can show that summation of alpha I square we have to minimize times summation of 1 square is greater than equal to what? Summation of alpha I whole square. You know summation of alpha is what? 1. So you get what? Summation of alpha I square is greater than equal to what? Here it's n, summation of 1, n times. It will be n. So it's 1 by n. So therefore the minimum happens at, the minimum value is 1 by n. So let's see when it's minimum. So it's alpha I by 1 is equal to lambda. That is only minimum. And let's find it out. So therefore summation of lambda square is equal to 1 by n. So we get that n times lambda square is equal to 1 by n. So lambda, value of lambda must be 1 by n. So we get that alpha I must be equal to 1 by n, all of them, to get the minimum value. And in fact, for alpha I is equal to 1 by n, it's summation of 1 by n whole square, which is 1 by n. So therefore the minimum value is actually attained. Okay, all of you understood the argument, guys? So therefore the best linear unbiased estimator is nothing but the mean for mu. The sample mean is a very good estimator. You need to understand this, guys. You need to understand the proof, guys, by this. All of you understood it. It's very important, this type of proofs. Very good, superb.
Sir, can you show the last step again?
Sure. Very good. Super. Is it fine with you now, guy? Nikhil?
Yes.
So, Shan, I understood that this is a very good way of generating a, an unbiased estimator, okay? In fact, you can find an unbiased estimator for, um, maybe like, in some other, like, it's exactly it's a type of thing that led to the discovery of this blue. So, but maybe you can not do this for general stuff, but if I ask you to find an unbiased estimator for sigma square, it will not be blue, okay? So how can you find it? So the best way is to use MLE or method of moments, okay, and change it by a constant that leads to an unbiased estimator. For example, have you done the problem on uniform? Do you know an unbiased estimator for uniform 0 comma theta ka theta, Shana? Do you know it? How to find it?
So,
So do you know how to find an unbiased estimator for the theta of uniform 0 comma theta?
2 times of x and bar
2
into x and bar sample mean.
2 into xn.
Yes. X and bar sample mean.
Oh, 2 into
Because
x
x
and
and
bar.
bar is. Yes.
Okay. That's a very good idea. Yeah, that's an idea. That's a very good idea. So that's a very good possible way of finding it. Okay. Also, do you know what's the UMVV, Shaina, of that?
It's n plus 1 over n into.
Very good.
N
So do
to
you know
power
how to find it?
starts.
So you use.
Yes, sir.
Very good. So yeah, that's it. Super. So that's how we find it. Okay. And by using all this stuff. Okay, so I think we can do some problems on consistency since we have not done consistency, but let's see. Just give me a minute. Just give me a minute. Okay, so we will do another consistency problem that Shana since told that she's facing problem in, and yes, so consistency problem, and then we will show something else. Okay, so let's see how we can prove consistency. I have shared the ideas how to prove consistency. Now I will again share the ideas of how to prove consistency again, and then I think I will end the class. Oh, I think we can do. Yeah, we will do a few completeness problems actually. So let's see consistency problem. So to prove consistency, we need what? We need the following ideas. Number one, we can use the result that expectation of the theta hat n is converging towards the mu. That is the bias is it's asymptotically unbiased called. And the final fact and variance of theta at n is 0. This is one of the cases, but it's not if and only if. Okay, you can check if this condition doesn't hold, then don't do it. It may not happen. The second one is first principle. Calculate the probability of this. Probability of theta hat n minus theta greater than epsilon, and it will get a sequence of numbers, show that it goes to 0. From first principle. And the final and the most important one is this. One of the most important one is this, that MLE is consistent. You can use this idea. Only, so understand also, MLE you can only use. This is something where I also got stuck in my first year at ISI. That MLE is only associated with its distribution. If a sequence or if a sample doesn't, you don't know the sample ka distribution, you cannot find the MLE, because MLE is based on the distribution of the XIs. If you just know mean, variance, and those stuff, summary statistics, summary data, like summary parameters, then you cannot find the MLE. MLE ke liye you need to find out the log likelihood. The likelihood involves the joint distribution. The joint distribution involves individual distributions. So for MLE can only be got if you know the distribution. This is something important you should remember. And using that, although MLE is not useful here, but you can use this criteria. MLE is consistent. Also, the properties of improbability convergence. If you don't know this, please watch our previous videos. I think Uttaran and Shoham has done it in details, very details. Like if you know xn converges and yn converges in probability, then xn plus minus multiplied by yn also converges and stuff like that. So you can check those. Okay, those are very, very important. So you can easily understand this is not applicable here because we don't know the distribution, right? You have to use something like this. And the best thing you can easily understand, you cannot find it here because you don't know the probability distribution of this. You also cannot find it using this. So therefore, the only way that is left is this. So let's try it out with this. Okay. Easily understand, we don't know the probability and the MLE both requires the aspect of what? Both requires the aspect of the distribution assumption, which we don't know. So we will use it directly here. So let's find out. So let's find out this. So theta hat n is one by twice n times n plus 1 summation of I from 1 to n I xi. And let's find out the first with expectation of theta hat n. You will understand just the basic stuff. It's I mu. Okay, because and you can easily understand it's mu times what? It's mu times. Did I do some mistake? Yes, I think it is something different. It's not here, it's here. So it's mu times what? N into n plus 1 by 2, that's the sum of I times 2 by n into n plus 1. So it gets cancelled. So you get it's unbiased, you get it. It's unbiased. But whether it's consistent or not, that you have to check. Whether it's consistent or not. Let's check it. So variance of theta hat n. So once you do the variance, this automatically gets a square 4 by n square times n plus 1 square times variance of this, it's summation of I from 1 to n I square variance of xi, that is sigma square. So understand, you can easily tell it from here that it's actually consistent. Can someone tell me why? Without calculating further. Any ideas how? Any ideas how we can do this? So we can do this. So summation of I to the power k, when you sum it up, it becomes n into, it degrees turns out to be k plus 1. So if it's summation I square, if you know that, I forgot the result, but I am sure that it's something like this. What I can know is it's of the degree n cube, sometimes some constant. Okay, and times sigma square, and नीचे वाला is, you see, the degree is n to the power 4. ऊपर is n cube, which is n to the power 4. So this must go to 0. This must go to 0. And therefore, you see how we have these three principles and we eliminated the options just because we don't have the distribution assumption. So it can help you in this problem solving strategies are super important for your quick solving and ideas. So I'm not a preacher of this, but since the exam is front, I am preaching this stuff because before the exam you need to find this stuff, use this stuff and get accustomed with it. So this is the whole idea. And yep, that's it. And we have got that. We have finally find out this. So this is the most easiest one, but these are also very, very helpful. I have told you stories of this, how this helped me in my ISI semester examination, so that this problem can come. Sometimes it's easier to find the probability of this rather than finding this stuff. Okay, good. So okay, perfect. So we have found it as a consistent estimator. Let me do some problems. I hope all of you understood this. Did you understand this, guys? All of you understood this, I hope. Very good. Super. Okay, lovely. And let's move on to some completeness problems. And let me check out the problems I have. So I will end with one thing. In fact, I did this problem. I remember this problem that it was given in IIT JAM, but I made an generalization of the problem. So let me just, I forgot the problem actually. It was about the discrete one. Okay, let me just check. I have that. Just give me a minute. Sufficiency. Yes, I got it, I guess. Okay, yes, I remember. I got it. So the question asks this. I will end this problem. It's a bit involved. So also it's not asked in the exam, but I generalized it. Find one. So I will just focus on one of them. So it's asked. Let's not focus on the second one. Let's ask to the first one. The first one के लिए it's asked x is complete and what like x is not complete. Okay, the first one के लिए it's a probability distribution of two discrete random variables and it's asked whether it's x and y are complete or not for this. So we'll observe how we can prove it mathematically. See, completeness part is a bit more, it's a bit more heuristic in some sense because it's not really easy to find that. But you can use number one, exponential family idea. Number two, you can just, do it from the first principle. So number one is exponential family. An exponential family is some that TIs are, those are the things that are sufficient, those are complete only. Okay, the estimators that are sufficient, those are complete only. Okay, and yes, so number one step is exponential family. Number two is first principle. And we'll see how first principle is useful in many cases. Like this here. I will show it. So let's focus on this. There's one hack you must understand. What is the definition of this completeness? Often we get confused. Not hack, but this is a definition. That T is complete if expectation of g theta is equal to 0 implies gx is 0 for this part. Many people miss and they get confused. For or on the support of T. Okay, on the support of T, where T is greater than 0, the probability or density is greater than 0. This is something really important and I will show you now how. So let's find it out. So here it's a discrete 1 2 and a 0 1 2 is here, so it's 0 1 and 2 are here and uska probability is 2p and 1 minus 4p, the corresponding probabilities, where of course p is less than 1 by 4. That is very natural to understand. And let's find out g of theta. So you can see we can use Lotus, the algorithm Lotus, that we don't need to find the g of theta ka density. We can just do it from the Lotus. Okay, that we just find the expectation of g theta if we know that t. Okay, g of t, I am so sorry, g of t. So let's find expression of gt, and we don't know the t over here. That's a bit of an issue, but how to find the t? That's the question. How to find this t? How to find this t? We will come into that, but let's check why this is not a complete one. So it's asking x is just an observation. It's asking whether x is a complete statistic or not. X is just one observation. So therefore it's asking expectation of g of x is equal to 0. So therefore what we get? Expectation of g of x is what? Expectation of g of x is g of 0 times 2p. We are using the Lotus, plus g of 1 times 2p plus g of 2 times 1 minus 4p is equal to 0. And if we do that, we get a polynomial linear function in P. Observe that twice P times G0 plus G1 minus twice G2 plus g2 is equal to 0. So we get a linear function in P. And since it's 0, we can easily tell that equating the polynomial, the coefficients are 0. So we get g of 2 is equal to 0, and g of 0 plus g of 1 minus twice g of 2, that is equal to g of 2, which is equal to 0. So we get that g of 1 is equal to minus g of 0 equal to 0, and g of 2 is equal to 0. This does not imply that g of x is equal to 0 on the support. What is the support of t? The support of x is 1, 0, 1 and 2. Therefore, g of 0 is not 0 on the support of t. Okay. G of 0 is not 0 on support of t. So therefore, x is not complete. Okay. Let's do the same problem here. Remember, it's p by 2, 4p square, and 1 minus p by 2, and 1 minus 4p square. So here it's 1, 2, 3, sorry, 0, 1, 2, p by 2, 4p square, 1 minus p by 2 minus 4p square. So let's find expectation of g of x. G of y rather. So that's the y is complete, we are checking or not, okay? That we are checking. So expectation of g of y is what? G of 0 times p by 2 plus g of 1 times 4p square plus g of 2 times 1 minus p minus 2 minus 4p square. Okay, and we get that. Let's find, it's another polynomial in P. So let's find it out. What is the polynomial? So p square times what you get? 4p square times you get g1 minus g2 plus p times what you get? g0 by 2, p by 2 times g0 by 2 minus g of 2. Very good. Plus g of 2. That is what you get, and it's equal to 0. Expression of g of y is equal to 0. That's what I get checking. And we get what? By equating the coefficient, we get g of 1 is equal to g of 2 is equal to g of 0 is equal to, you see, g of 2 is equal to 0, so it's 0. So we get the g of x is 0 on the support of t, that is on the support of y, that is 0, 1 and 2. So therefore, y is complete. See, the support of thing may sometimes you will miss it. So doing it with the first principle is really helpful. Otherwise, you can just do the fact that the exponential family ka is like, we have to, like, the main ideas used are this equating the polynomials or differentiation with respect to the parameter to get it to 0. That's it. These are the two things we can use to find z of x equal to 0 or not. Did you understand the proof, guys? Did you understand the solution of this? All of you understood this, guys? Very good, very good, superb, superb. Okay, fine, good. So this is all I have to discuss with you today. I think you are quite confident. Like, practice more problems on completeness. The best thing to do on completeness problems is this. Result is this, doing this. I will give you a set of problems. So do this. many of them. Yeah, there is no place left, so I will just clear this one up and give this problem. Yeah, do this one. And for all the, so find the sufficient complete statistics and criminal law bound and information function, all of them. So it will, and also the consistent estimators, whether they are consistent or not. So check that. And you can find sufficient statistics. You can use MLE. Okay, you can find all MLE, MOM, sufficient, complete, CRLB, everything for this. Okay, and consistency, whether they're consistent or not. Check all of this for all this set, and it will be a very very good exercise to help you revise the algorithms of the corresponding all the topics out there. Okay, so any doubts you want to share with me? Because I think we have, or I have discussed all we have done, like I have planned to discuss with you. Yeah. Okay. Thank you guys and all the best. And I will see you in the next class soon. Bye bye. And yep, that's it. Bye.